In 1916, a chemist called Gilbert A. Lewis came up with the octet rule. The idea that an octet of electrons in the valence shell was the most stable arrangement of any atom. Now this is achieved by either becoming an ion or by covalent bonding. Covalent molecules are formed when valence electrons are shared between atoms to achieve a stable electron configuration, just like the noble gases. Electrons can be shared between atoms that are the same, like diatomic hydrogen. In this case, a molecule of hydrogen is formed when each hydrogen atom shares their valence electron, and this leads to a more stable electron configuration. Different style symbols can be used to represent their valence electrons. These are known as Lewis electron dot diagrams. Because one pair of electrons are shared, a dash can also be used to indicate the bond. In the case of a water molecule, an oxygen atom with a valency of 6 shares a pair of electrons with each of 2 hydrogen atoms. This once again allows each hydrogen atom to achieve a stable helium-type electron configuration, and the oxygen achieves a stable neon-type electron configuration. Just like before, a dash can be used to indicate a shared pair of electrons. Now, because we're dealing with 2 different elements, the sharing of the electrons may not be equal. In fact, due to a high electronegativity of the oxygen atom, it tends to hog the sharing of those electrons, giving that region a slight negative charge. Conversely, the hydrogen atoms have a very low electronegativity, so tend to give up the electrons much easier in the bond, giving their region a slight positive charge. This means the water molecule is polar, as there are now regions around the molecule that exhibit slight positive and negative charges. This explains why a stream of water can be bent if introduced to a magnetic field. Covalent molecules tend to be non-metals bonded to other non-metals. The covalent bond that exists between the molecules are very strong, but how? If you look at the hydrogen molecule, that is 2 hydrogen atoms covalently bonded, the area in which the electrons are shared can be thought of as a region of negative charge. Now, it's this region that attracts adjacent nuclei which hold the atoms together, as in opposites attract. So in order to separate the elements from each other, enough energy is required to overcome this bond. Intuitively though, the more electrons that are shared, for example in the oxygen molecule, a double covalent bond exists which creates a stronger region of negative charges. This in fact means the nuclei of adjacent atoms are even closer because of the stronger attraction. Therefore, even more energy is required to overcome this bond, if you were trying to break it. What about a triple covalent bond, as in the nitrogen molecule? You could probably work this out on your own.